All right, so continuing on with 8.1 and 8.2, let's just do a brief summary of what we just laid out. So we basically had to restrict the domain of our 6 trig functions to define inverse trig functions. So by doing so, we are restricting the quadrants for which the angles that refer to these trig functions can exist. So, because when we were talking about sine inverse, because we restricted sine from negative pi over 2 to pi over 2, then when we're finding that angle for sine inverse, we will either draw that angle in quadrant 1 if it's positive, or quadrant 4 if it's negative. Now, with cosine, think about how we restricted cosine. We restricted cosine from 0 to pi. So that means that we were operating in the first quadrant when positive, and in quadrant 2 when negative, from 0 again to pi. Tangent we're restricted to, again, negative pi over 2 to pi over 2. So again, we're talking first and fourth. And now the reciprocal functions follow suit except for cotangent. So cotangent, again, because of the way those asymptotes fall, the way we look at one period of tangent of cotangent x, we restricted from 0 to pi, again limiting us to the first quadrant and the second quadrant. Although secant and cosecant will follow the same patterns as sine and cosine. So cosecant will be in, let's get that same color as sine. So cosecant also restricted to first and fourth. And secant also restricted to first and second. All right, so let's do some examples and see if we can't make sense out of all of this. All right, so kind of back to what we started with in the beginning of the first video. If we're asked to find an exact value, and we're going to find an exact value of sine inverse of negative 1/2. Okay, so basically what this means is, all right, sine theta is equal to negative 1/2. Find that angle. So the inverse function is theta. That's what I'm looking for. What angle is sine equal to negative 1/2? Since the inverse function with sine, I'm restricted to the first and fourth quadrant. Because 1/2 is negative, that tells me I'm looking for an angle in the fourth quadrant. So I'm looking for this angle. So when is sine theta equal to negative 1/2? Well, you should think about your 30-60 triangle. So 30 sine of 30 would be 1/2. So in quadrant 4, it would be negative 30. So sine of negative 30 is equal to negative 1/2. So sine inverse of negative 1/2 is equal to negative 30 degrees, or pi over 6 radians. What about, let's try cotangent inverse of negative 1. Okay, so when cotangent is negative, when I'm talking about the inverse functions, so that was restricted from 0 to pi. So negative cotangent, I'm looking for an angle in quadrant 2. So I'm looking for a quadrant 2 angle. So if I'm going to think in terms of the triangle, that reference angle I'd be coming up with would be this one. So what triangle comes to mind? I'm thinking about that 45, 45, 90 triangle, because I know both legs are 1. And cotangent is our adjacent over opposite. So 45 degrees would be that reference angle. 45 degrees, or pi over 4 radians, right? So what angle would this be? This angle would be 180 minus 45, or 135. Or in radians, it would be pi minus pi over 4, which is 3 pi over 4. So cotangent inverse of negative 1 is 135 degrees, or in radians, 3 pi over 4. You just need to pay attention to what you're being asked to find, whether it's in degrees or radians. All right, you might be asked to use your calculator to come up with some of these. So when using the calculator, again, you just want to make sure you practice with that Windows calculator. So let me pull it up real quick. Probably the ones that would require more thought would be your reciprocal functions. So let's start with a regular function. Like, let's say, okay, cosine inverse of negative 0.44 in radians. So what is that value? All right, so I'm going to pull up the calculator, because this is more or less saying cosine of what is negative 0.44. All right, so the inverse trig functions you'll see once you click on inverse. Then you'll see all the inverse trig functions. Don't click on the ones with the h's. Those are hyperbolic trig functions, and we're not looking at those. So first we would enter the argument. So I would enter the 0.44, make it negative, and then inverse cosine. So this is equal to, and again I'm in radians, so note that we have radians checked on the calculator. So this value would be 2 point, I think that said 02, and again that's in radians. And note that that would have to be an angle in the second quadrant, because if the argument is negative, I've restricted cosine to the first 2 quadrants. So think about it, 2.02, would that be in between 0 and pi? Well, pi is around 3.14, so yeah, 2.02 would be an angle in quadrant 2. So just always good to kind of cross-check. All right, let's check out a reciprocal function, make sure we're okay with that. So let's say secant inverse of negative 1.28. All right, this time why don't we do degrees? All right, so what we're going to enter is cosine inverse of 1 over negative 1.28. All right, so let's pull that calculator back up. 1 over 1.28, make it negative, equals, and then inverse cosine. And that gives me, again, this one I did in degrees, so that gives me 141.37 degrees. All right, so like I said, the functions and the reciprocals work similarly, but where you could run into trouble is with tangent and cotangent because they're not the same. Tangent we're restricted from negative pi over 2 to pi over 2, but cotangent we're restricted from 0 to pi. So they're a little bit different when you're finding values. For example, it's with the negative. So if I have cotangent of negative 1.2357, I have to use the tangent inverse function of 1 over that amount. But what's going to happen? The calculator is going to give me an angle down here in quadrant 2, but my angle needs to be over here in, I just said that opposite. The calculator is going to give me an answer in quadrant 4. My angle is going to need to be in quadrant 2. So let's see how we'll account for that. So bringing up the calculator. All right, so we have 1 divided by 1.2357. Make it negative. Where's that button? So that's that. Inverse tangent. So that gives me an angle, like I said, of negative 38.98 degrees. So if I don't want that, again, I don't want that angle down here. I want it over here in quadrant 2. So I just need to add 180. So cotan inverse of this negative number will be equal to about 141.0.